NTK is introducing a new cutting tool material called Bidemics for high-temperature alloy machining. Carbide was first developed in 1927. Since then, various other materials have been developed for cutting tools. The last cutting tool material developed for machining high-temperature alloys was whisker ceramic in the late 1980s. NTK released the newest material classification called Bidemics to the world in 2014. Both JX1 and JP2 are brand new insert materials which can replace traditional whisker ceramic, Cylon, and carbide in most high-temperature alloy machining applications. Bidemics has much better wear resistance and toughness than any existing insert materials. Bidemics is NTK's proprietary patented material composition. This test result shows Bidemics has 3 times the toughness when compared to whisker ceramics at the typical cutting edge temperature of 1200 degrees Celsius. JX1 is best applied for non-scale roughing and semi-finishing process of high-temperature alloys. JX1 has 4 major strengths. First, longer tool life than whisker ceramic. Second, up to 1600 SFM capability. Third, machines the latest high-temperature alloy materials. Fourth, provides superior finishes on machine parts. JX1 can achieve longer tool life with the same cutting conditions as whisker ceramic. This is a laboratory comparison trial with JX1 versus whisker ceramic. While machining Inconel 718 at 1200 SFM, whisker ceramic starts getting wear on the first pass as the sparks indicate. JX1 easily completes the whole machining without sparking. On the second pass, whisker ceramic continuously wears, showing increased sparking towards the end of the pass. JX1 could complete the second pass with minimal sparking at the end. The trial insert photos show wear pattern results from the test. JX1's edge wear validates better wear resistance and shows much better notching resistance than whisker ceramic. This is a field test result on Inconel 718 with no scale, running at typical whisker cutting parameters. JX1 had more than 3 times longer tool life versus whisker ceramic. JX1 can machine up to 1600 SFM on non-scale, high-temperature alloy materials. When machining Inconel 718 at the speed of 1600 SFM, whisker ceramic starts showing sparking immediately due to the insert chipping. JX1 shows no sign of sparking at all. Whisker ceramic could not make the second pass. JX1 still had no sparking. Insert wear after the trial verifies that JX1 demonstrates high cutting speed capability. This characteristic contributes to dramatically increased productivity. This test shows an Inconel 718 aircraft engine part being machined at 1570 SFM versus whisker at 800 SFM. JX1 increased the cutting speed by nearly 200% versus whisker ceramic in this production application. An additional advantage of higher cutting speeds is that chips break into small and manageable segments. JX1 can machine newer compositions of difficult-to-machine materials like powdered metal heat-resistant alloys. This application shows the results of JX1 machining a Rene 104 turbine disc. Rene 104 is a high cobalt-based aerospace alloy. It is one of the most difficult to machine materials using any existing insert grades. JX1 achieved 4 times longer tool life versus whisker ceramic. This data shows another positive test result when JX1 machines a 718 Plus engine case. JX1 achieves 3 times longer life versus whisker ceramic. JP2 is a coated multi-tipped insert for high-speed finishing of high-temperature alloys. 4mm brazed Bidemics tips provide greater machining stability. JP2 has 3 major strengths for high-temperature alloy machining. First, faster speed capability. Second, significantly increased wear resistance versus CBN. Third, superior surface finish on machine parts. JP2 can finish high-temperature alloys at speeds up to 10 times faster than carbides. In this Inconel 718 finishing application, JP2 machines at 800 SFM versus the typical carbide cutting speeds of 100 to 120 SFM. JP2 shows the best wear pattern when compared to CBN or whisker. Obviously, carbide can't machine at 800 SFM. This data shows the results of JP2 machining on Inconel 718 turbine disc. JP2 could easily machine at 800 SFM, where carbide can only machine at 70 SFM. Production increased more than 10 times by only replacing carbide with Bidemics JP2. JP2 shows superior wear resistance when compared to CBN or carbide. JP2 excels with better surface finishes. JP2 shows better wear resistance than CBN at the same cutting parameters. JP2's outstanding wear resistance and notching resistance result in workpiece surface finishes consistently superior to either CBN or carbide. NTK is entering into a new era of high-temperature alloy machining. NTK's Bidemics is not carbide, not ceramic, and not CBN. It is Bidemics.